I would love to invite our first speaker to the stage, Shayan from the Sui Foundation, to give an introduction to the Move programming language workshop. I've met Shayan in multiple countries in the last couple of months. I've seen him, and we have kind of an inside joke that we see each other more than our own parents. We saw each other in Taipei, Hong Kong, ETH Denver. Shayan actually spoke at our first MoveCon at ETH Denver. And so we've seen each other quite a lot. But it's great to have Shayan here, and I would love to invite him to the stage. All right.
Oh, awesome. Cool. Thank you so much for having me. I'm kind of like annoyed you stole my joke, because if you didn't say that whole part about like us seeing each other more than our families, I would have said it. But no, you stole that, so I'm kind of annoyed.
I totally stole it. I use it. I use it all the time.
But yeah, first and foremost, thank you so much to the Super Oracle / like Moved Out team for having me. I'm gonna make it like a personal goal of mine to come to every single Moved Out event this year. I'm 2 for 2 so far. I'm a speaker for 2 for 2 so far, and yeah, like I said, I just like love the ecosystem. I love talking to builders. I just like love being like on the ground, virtually on the ground right now. But like, yeah, I love what I do. Yeah, I'm happy to be here. So yeah, before we get started, I'd like to introduce myself. My name is Shayan Sanjideh. I am a developer relations engineer at the Sui Foundation. And today we'll be going over an introduction to the Move language. So why Move? So in Move, assets and ownership are encoded in linear types. So what does this mean? It means essentially that when you're reading a function or you're reading the code, it's very similar to how you would think of it in like plain English. So for example, if I say something like, if you give me a coin, I will give you a car title. In a move function, that would look something like, if you're calling a buy function, it takes in a coin as a parameter and a car title as a return value. Similarly, if I say, if you show me your title and pay a fee, I'll give you a car registration. So again, showing a car title, a read-only reference, pay a fee, passing in a coin, buy value, and then it outputs a car registration. Another big thing is that Move has a type system that prevents misuse of asset values. So what does this mean? So essentially, Move is here to be a flexible programming language to give developers all the tools they need in order to succeed, while at the same time preventing themselves from shooting themselves in the foot. Because if you can, you will. So you can look at these code examples, for example. You look at these code examples that say how you can demonstrate how these 3 errors are invalid. So you can't duplicate, you can't double spend, and you can't destroy coins. And because at the end of the day, assets are so fundamental to blockchain, you want to be able to have assets as like a first class citizen on a particular network. So this type system ensures that these digital assets behave like physical ones, right? If I have like a phone in my hand, I want to give my phone to someone. That phone, I don't want to accidentally duplicate my phone. I don't want to spend it twice, and I don't want to be able to accidentally destroy it. So all these type systems that are baked into the VM prevent developers from doing that. So before we go further, so this disclaimer, this is an introduction to Move, but because Core Move and Sui Move have like differed quite a bit, I will be focusing on Sui Move, and I'm like repping the merch, as you can tell, gotta stay repping. But yeah, the overall concepts will carry over pretty well between Sui Move and Core Move. So without further ado, let's talk about objects. So this is like the most rudimentary object you'll see written in Sui Move. You'll see that it has 2 things. It has the has key keyword and UID, unique ID, as its first field. So the has key keyword indicates that this is an object that will be written to global storage, i.e. you'll be writing this to the chain. And then the UID stands for unique identifier, is a unique global identifier that every object has when it is first created. And in Sui Move, Objects can be either owned by an address, so this is like this would be like you having an NFT in your wallet. Objects can be owned by another object. So if you want to like think, for an example, if you have like an RPG character in a game, you can like equip a sword, right? Both you, the character, and the sword would be NFTs or objects, and they'd be owned by each other. Or to be more specific, the sword would be owned by the character. Objects can be shared. So shared objects are really big because they create, there's a distinction in Sui between single writer objects and shared objects, and we'll talk about that in a bit. And then immutable objects, which means essentially a mutable object is a shared object, but no one else can mutate it. So before we go further, before we jump into an example, we kind of like to joke. We always say like that there really is no difference between an object and an NFT, right? So every object has this unique identifier that allows no two objects to ever be the same. So if you have like two swords in a game, they'll still have two unique identifiers, so they will never be the same. They'll never truly be the same, which is why we like to joke and say that technically there is no difference between objects and NFTs, because we're so used to hearing NFTs. If making this association helps you, then go for it. So now let's actually see some Move code in action. So in this example, or in this series of examples, we'll be going through like a particular like car racing game. So I love this example because I think if you want to really have an introduction to like a new programming language, seeing like complex syntax or weird docs thrown at you might be a little confusing. So what I like to do is to go to this example. So if you were younger, or maybe you weren't younger, maybe like last week, if like, you went to an arcade and you were like playing in a car racing game where like you're sitting behind a wheel and you can like pick different types of cars, and you'll realize that like depending on the type of car you pick, there's like different types of stats. There's a different set of stats. So for example, sometimes you might pick a car that has really high speed and really high acceleration, but very poor handling. Or maybe you can pick a car that has very good handling, but like lower speed and high acceleration and so on, right? So we've all played those games where you can like pick different types of cars and actually race them. So this smart contract demo, or this module demo, is going to emulate that to see how we can create on-chain games using Move. So before we take a look at the actual struct, let's just go through everything. So you'll first see that this smart contract has the word module at the top. So in Move, we don't call smart contracts, we call smart contracts modules. The first car you see refers to the actual package name. So because this is a series of examples pertaining to cars, I'm just naming it car. And then the second car is referring to this particular module. Next, we have a list of imports. So we're using a Sui object, transaction context, transfer from the Sui standard library. And then the first real bit of Move that we see is this struct car. So as you remember, we said that every object in Sui Move has to have two things: the has key keyword and UID. So this also has the store keyword, which means that we'll be able to store this car inside other objects, and we'll get to why we need this later. But essentially you'll see that it has the two things we need: has key and UID, and then the three fields that we were talking about. So speed, acceleration, handling. So if you can imagine, if we're playing like an on-chain game, our car can be represented by this actual car object or this car NFT in game, and it can have that variable speed, acceleration, or handling. Next, we want to talk about how can we instantiate this new car object. Super simple. All we have to do is call this new function. So all we have to do is pass in the three variables we were talking about: speed, acceleration, handling, and then to pass in this mutable reference to the transaction context. What that means is and mute transaction context. So essentially the transaction context is an object that provides information about the transaction currently being executed. And whenever you want to instantiate a new object, you need to pass it in as a parameter. So again, simple as that. In order to create a new object, you just pass in the 3 values you need, the transaction context, and then, yeah, you just output a car. And as you can see, this function returns a car. So it talks about that linear in typing that we were talking about earlier. So yeah, all you have to do is just, type in car, open up a bunch of curly brackets. ID is always going to be new, object : new from the Sui standard library because we're instantiating a new object. And then similar to Rust, you can prune the fields. So we're pruning speed, acceleration, and handling just because they're the exact same as what we passed in. But then you saw that that function doesn't really do anything. We're returning a car, we're instantiating a car, and we're returning it, but that's about it. It doesn't go anywhere. So now we want to call this create function. So what this create function does is it calls new, it instantiates that car, and it transfers it to the person calling this function. So that's what you get via the transfer : transfer API. So the transfer API says the first parameter is always the object, so the car that we just instantiated, and then the second one, transaction context : sender, refers to the sender of the function, aka the person calling this function. So what does this function do in a nutshell? It essentially creates a new car and sends it to yourself. And then you might think, okay, what if I want to now transfer this car to a friend of mine? Can I just call the transfer : transfer function? No. Unfortunately, because you cannot call the transfer function directly, the Sui standard library transfer function directly, you have to call this wrapper function around it. You have to create this wrapper function around it. And again, all you have to do is pass in car by object, and then the recipient, which is the address, and call the function like that. Next, let's say in our game we want to create, let's say we want to get the stats. So how would that look like? So again, very similar to car, you can pass in a read-only reference via ampersand. So if you want to call get stats, you'll simply pass in a car as read-only reference. It'll return 3 U8s, and yeah, the next line just simply says speed, acceleration, and handling, and it'll return those 3 values. Next, upgrade speed. So let's say you're playing a game and you do very well, and you want to now upgrade your speed in this game. How would you be able to do it? So instead of passing your read-only reference to the car, you'll pass an immutable reference because we're mutating this. And again, this is super similar to Rust. So if you have any Rust experience, it'll look pretty similar to this. And then the amount by which you want to upgrade it by. And then the actual logic is not that difficult. Self.speed equals self.speed plus amount. So to recap what we just went over, Sui utilizes an object-centric programming model. Objects are now first-class citizens on the network, and objects represent ownership. If you own a car, if you own this car object, it's actually inside your wallet. You actually own it now. So let's talk about this. Go through this module now. Car admin. So we have the same imports, and you'll see that we're importing car from the actual car from the previous module. So that's why we needed to have store, because we're able to store that car inside this other module. And then you'll see we have this object called admin capability. And you know it's an object because it has the 2 things every object has to have. It has keyword and the unique ID as its first field. In this case, its only field. So now let's talk about this function, init. Whenever you want to call an init function, so init function is special because it's only called once, and it only looks like its function signature is always the same. It's just a fun, and its only parameter is the mutable reference to the transaction context. So because this function is only called once when a module is first published, it's very useful for doing anything that you don't want to ever happen again. So for example, what are we doing here? What we're doing here is we're instantiating a new admin capability, and we're sending it to the function sender, which in this case is the person publishing this module. Essentially what that means is that the person who publishes this module essentially will have an admin capability, will have admin abilities for certain functions, and we'll see soon. So for example, previously in the previous create function, you saw that it was just speed, acceleration, handling in the transaction context. But now there's this underscore, colon, and admin capability. What does that mean? It's essentially saying that now anytime someone who wants to call this function now has to have this admin capability in their wallet. And it's only an underscore because in Move, anytime you want to make sure that you want to use an object in a function, but you don't want that object to be returned by the end of the function, you'll prefix it with an underscore. So because we're not doing anything with the admin capability, we're basically only checking to see if the person calling this function has it. We just leave it as that underscore. And then exactly, we just have to call car :new because from the previous function. And then we have to now call transfer : public transfer because this car was instantiated, the actual car object was instantiated in the previous module, not in this one. So we need this public transfer API to indicate that, okay, because car wasn't instantiated in this module, it will be borrowed from the other one. So to recap, the init function is a function that's only called once when a function is published, and capabilities can be used to gate admin access for functions. So for our last example, let's now talk about this car shop. So we have a bunch of imports, we have this error message, insufficient balance, and again the same car import. So the biggest difference now is that we have this car shop. So this car shop is an object because it has key and UID, and it has price and balance Sui. So price refers to a price of a car that we'll be using to purchase cars, and then balance Sui refers to the actual Sui tokens that will be inside this object. Because as you remember, you can store objects inside other objects. So actual Sui token is an object, and we're storing that object inside this object. And then similarly, another admin capability that we're calling shop owner cap. So now we have the same init function, but it does two things. So as you can see, instantiate admin cap and send it to the publisher of the package. So we create the new shop owner cap and we send it to whoever's publishing it. And we instantiate this car shop shared object that we use to purchase cars. So what is a shared object? So we were talking about it earlier, but essentially a shared object is an object that anybody on the network is able to interact with, within certain parameters, of course. So one of the biggest things that Sui does is that it has that difference between single writer owned objects, so like NFTs, or like what you would think of like NFTs or tokens, and then shared objects like this car shop that we'll see in a bit how it's used. So now, if we want to buy a car, we have to pass in three parameters, right? The actual car shop shared object, the payment, which is our coin, our actual Sui, and the transaction context, because we're creating a new object, we're creating a new car. So you'll see, line 40 says, assert coin value payment is greater than or equal to shop price. That's essentially saying, okay, you need at least more Sui in your balance than the price of the car. And the actual meat of the function, we say, you can read it yourself, but like coin balance equals coin balance mute. Essentially, these are just like APIs from the Sui standard library, but what it's doing is it's essentially taking that coin that you presented in the function, unwrapping it, and you're getting the balance. Then what you're doing is you're taking that balance and you're setting it equal to paid, and then you call balance : join to append that paid to shop balance. So long story short, you're just taking that Sui that you own and you're depositing it in that shared object. And then finally, instantiating and transferring the car to the user calling the function. So you can think of this as like a default car, right? It just has 50 for speed, acceleration and handling, and of course the transaction context because it's instantiating the new object. And then we're calling transfer : public transfer because we're sending that car to the person calling this function. And then earlier we talked about why we needed the admin capability. So like I said earlier, because car shop is a shared object, anybody can interact with it. But similar to how anybody can go into a store, right? Anybody can go into, I don't know, like a clothing store to buy clothes, but not everybody can open the cash register, take all the money out, and leave. So similarly, we don't want anybody being able to you don't want to provide access for anyone to collect profits, right? So what do? We guard it via an admin capability. So again, we just prefix it with the underscore because we don't want, we're not using it. The admin just needs to have it in their possession, the actual car shop and transaction context, because we're creating a new object. We're taking that balance and we're wrapping it into a coin. And similarly, all we have to do is we just take that balance that's in the car shop, we wrap it into a coin, and then we send it to the admin, the person calling this function. And the reason why we need to wrap that balance into a coin is, and you'll see this more if you look at the actual Sui framework docs, is that balance isn't an object. So you're not able to send balances to people, you're only able to send coins. The best way to think about the relationship between balance and coin is that coin is just a wrapper over balance. And then you just call public transfer to send that coin to the user. To recap, shared objects are objects that can be accessed by anyone, and Sui's design architecture allows for transactions involving single writer-owned objects to forego consensus and reach near instant finality. So because shared objects have to go through consensus and single writer objects don't, Sui is able to reduce latency by being able to have certain transactions forgo consensus altogether. And just a quick show, because I see time's almost running up, I just want to talk about the Encode Club series. So if you enjoyed this was a little short, but if you enjoyed this and you do want to learn more, please go to the Sui Foundation blog and look up What's Sui, Encode Club Sui series number 1, and you'll see a total of 6 videos where I talk about Sui Move in greater depth. And that's it. Before I leave, I just want to say thank you so much to John, Super Oracle's Moved Out team for doing this again. This was not my first DAO, and it's definitely not going to be my last.
Thank you so much, Shayan. That was great. I'm personally really interested in the object-oriented aspect of Sui, and I'm excited to hear some of our panels coming up, our gaming panel and the DeFi panel, to really talk about maybe more in depth if some of the projects are actually utilizing this object-oriented or centric model, where, like I've heard, a lot of things on Sui, like everything is an NFT. Everything is kind of unique in some way, and objects can own objects into infinity, which is quite interesting. And from your talk today, I learned that objects can also own balance. So you could have a character in a game that owns an item, and that item essentially could have a balance of Sui. So,
yeah, not even Sui, but anything.
Anything, right? So it seems very composable, and so it makes sense for me right away for gaming. But then I'm also really curious to see what could come through of this, how to use this object-centric language or model for finance in the future of DeFi. So it's really exciting for the future.
A bunch of, at least I know a few teams, I won't spoil, but I know a few teams both in gaming / NFTs and DeFi on Sui that are leveraging these Sui unique capabilities to do really cool stuff. I'm not going to spoil anything because you guys will get to see it firsthand.
Awesome. Thanks so much, Shayan.
Yep.
I'll see you very soon.